Hey guys, my name is Trevor Sullivan, and welcome back to my video channel. I know it's been some time since I've posted any videos. The last series that I was actually working on was some months ago, and it was a tutorial around Rust software development from scratch, really focusing on all the fundamentals, things like control flow and asynchronous operations and all that kind of fun stuff, even threading, which is a pretty interesting topic. But in this video, I wanted to shift topics a little bit and actually talk about an embedded programming language called Lua. Now, it's been around for a long time. It's been around since about 1993 here, and you'll see that it was intended to be a general embeddable extension language. So what that means is that Lua wasn't really intended to be a general purpose programming language. I guess you could use it for that purpose if you wanted to, but it was more designed to be embedded into other software so that you can provide some kind of automation interface to that software package. To give you some examples of software packages that actually incorporate Lua for automation are things like the nmap utility. It's a network scanning utility that you can use as a security person to look for open ports, ping a bunch of IP addresses, and that kind of thing. There's also Wireshark, which you can use to capture network traffic and inspect network traffic. Both of those utilities actually use Lua as a scripting automation language. And there's also a video game out there called Roblox, which I've never played myself, but I know it's very popular with kids these days. And Roblox has chosen to incorporate Lua as an automation language to extend that particular game as well. So we're not going to be talking about the specific extension interfaces, but I did just want to introduce the language to you. And once you understand the basics of the Lua language itself, then you can start learning about how to actually incorporate Lua scripts into other applications like Wireshark, nmap, Roblox, and any other applications out there that utilize Lua as an extension language. Now, Lua is kind of a high level language, I would say. It does run on top of a virtual machine. And when I say virtual machine, of course, I'm not talking about a virtual hardware machine where you have like a virtual CPU and virtual memory. But a virtual machine in the programming world is actually more of an interpretation layer that sits on top of the operating system. So it's not like C, where you're actually calling low level interfaces. It's more of a kind of intermediate layer where the Lua script that you actually write calls into the intermediate layer. And then that intermediate layer is actually calling the underlying operating system APIs on your behalf. And another great thing about doing it that way, of implementing the language that way, is that it supports garbage collection. So garbage collection is a feature of many different programming languages out there that automatically cleans up any variables, any memory that are no longer being referenced by your program. So if you're not interested in doing really low-level development where you have to worry about doing memory management and that kind of thing, then garbage collection will take care of that for you, and you can really just focus more on the actual business logic of your code. Of course, that does mean that it's not necessarily going to be a super high performance language like maybe C or C++ or Rust or Go might be. So it is going to be quite a bit slower than those languages. I haven't necessarily run any benchmarks myself yet, but I would imagine that having a virtual machine layer would introduce some performance challenges with this language. So again, you're probably not going to be building things like REST APIs with it or things of that nature, especially if they need to be high performance and scalable. But again, it is an automation interface for certain software out there. In fact, I even came across a Lua add-on for the Godot engine. So if you're a game developer and you're using the Godot, Godot game development engine, then you could potentially even use this plugin that allows you to run Lua scripts inside of Godot. So there's a lot of different ways that you could potentially use Lua, but you can just really focus on learning the basics of it and kind of use it like a general purpose language so that you can understand the language fundamentals itself before you actually start trying to learn about how it specifically integrates with certain software packages. So that's really the focus of this particular video, is to focus on things like control flow statements, how variables work, how modules work, and coroutines and things of that nature. Different, variable data types like numbers and tables and strings and Boolean values and things like that, right? So the best place to really learn about Lua, aside from, of course, this video, is the Lua documentation itself. So if you go out to the website at lua.org, you can go out to the documentation page right here. And then it's got this reference manual right here. And you'll see there's actually reference manuals for historic versions of the Lua runtime as well. So if we just want to drill into the most recent version, 5.4 here, we can see some of the basic concepts here. It talks about garbage collection. We've also got the language itself, talking about things like variables and statements, things like for statements, if statements, things of that nature. We've also got expressions here, so things like comparison operators, which they actually call relational operators. We've also got concatenation capabilities, the length operator, which we'll take a look at later. It actually uses the hash sign for getting the length of a string. And things of that nature, right? So we've got also module capabilities. We've got coroutines. That's down here under standard libraries. We've got talk about modules here, coroutine manipulation, how to actually define functions and call functions and pass functions around. It actually, to me, feels very similar to JavaScript in a lot of ways. Even the kind of object-oriented principles behind it, OOP, it feels very similar to JavaScript in certain ways to me. And if you're a JavaScript developer, I'd love to hear a comment from you, see if you think that this feels a lot like JavaScript as well, or if I'm just totally off base there. But to me, it does feel a lot like JavaScript because you can construct these kind of object-like things and then attach properties and methods to them. And it doesn't really have a strong type system like other languages like C# or Java, where you actually define classes and you have methods bound to those classes. It feels like that, but it's a lot more dynamic than that. Even PowerShell actually feels very similar in some sense because it's very dynamic. You can create objects, you can attach additional properties and methods to those objects. So it does feel a lot like those higher level languages, and it's not quite as strongly typed as something lower level like a C++ or Rust, for example. So anyways, you're probably wondering, well, how do I actually get Lua? How do I actually run Lua? And Lua is actually cross-platform. So right now I have a Linux system in front of me here. This is actually an Ubuntu Studio Linux system right here. So if I go out of full screen mode here, you can see my little menu bar across the top here. But you can also install Lua on Windows as well as Mac OS, and you can also run it inside of a containerized environment. I actually have it pre-installed on this Linux system here, but I'll show you how you can install it inside of a container if you don't already have it installed. So I'm going to go ahead and head over to a terminal right here, and I've already got Docker installed. I'd strongly encourage you to learn about how Docker works because you can use Docker to run pretty much any type of code, whether it's Rust code or Java code or C# code or Python code or PowerShell code. All those different runtimes, all those programming languages can actually be executed inside of a container very similar to Lua. Now, Lua, you can actually write scripts or you can actually use Lua interactively. If you're just initially learning about Lua, sometimes it's nice to just be able to kind of type in a little expression to see if it works inside of the Lua REPL, the read, evaluate, print. I can't remember what that final character is for, loop. That's what it is, read, evaluate, print loop. And so the REPL is really nice to just kind of test out simple expressions to make sure that you understand the syntax. But really what you're going to want to do is actually write a Lua script file and then execute the Lua interpreter against that script file to run it inside of the VM. Now, Lua also has a compiler binary as well. So you can actually compile one of your Lua scripts into a binary file. And so that's also installed along with the Lua package. So it's up to you whether you just want to call Lua to run the REPL or the interpreter, or if you want to actually run the compiler for your Lua program. So you can see if I just run Lua here, I've already got it installed, but we're going to use Docker here to actually run a new container instead. There's actually a generic container out there called the Ubuntu container, and I just tend to use Ubuntu because it's one of the most popular Linux distributions out there. But this is just a container. We're not actually creating a virtual machine. We're just creating a process level isolated container here. So if we do a Docker run, --rm, that'll just automatically clean up the container when I'm done with it, so I don't have these extra container files sitting around. And then I'll do -it to make it interactive here in my terminal, and then specify that container image. Now I've got a brand new container based on this Ubuntu image. So it kind of feels like a brand new Ubuntu virtual machine that's running in its own isolated container, but it's not a virtual machine. It's just an isolated process running on top of my Ubuntu Linux virtual machine. So then generally what we do is we want to update our package manager. So in this case, Ubuntu uses the apt package manager. If you're on a different Linux distribution, it might use the yum package manager or the zypper package manager. I think zypper is used on the SUSE platform. And so now that we've done an apt update to update our metadata for packages, we can just say apt install lua --yes. Actually, we have to specify the specific version here. So you can see there's packages for Lua 5.4, 5.3, 5.2, and 5.1. So unfortunately, I don't know why they don't have just a generic Lua package that kind of self-updates, but we do have to specify the version there, which I totally forgot on Linux. Now, if you're on the Windows platform, there's a really nice command line package manager called the Scoop Package Manager. So here I am on my local Windows system. This Ubuntu machine is actually a virtual machine that I'm using the remote desktop client to log into. But if we go to the Windows platform here, you can actually just do a scoop install on the Lua package to get Lua installed. And then I can run Lua right here on the Windows operating system as well. Just to show you, if I do Control-C, do PS version table, you can see, sure enough, this is the Windows platform right here. So it does run on Windows as well. And if you don't have the Scoop Package Manager installed, that's a community project, but I use it very extensively to keep a lot of my developer tools up to date. You can head out to the website at scoop.sh. So let's go to our browser here, go to scoop.sh, and you can very easily install this Scoop Package Manager on your Windows system, and then you can install the Lua tools using that Lua package. And that way, if a new version of Lua comes out and you do a scoop update Lua command, it'll just grab the latest version of Lua for you. All right, so that's how you can get it installed on Windows, and I don't have a Mac machine because I can't really virtualize a Mac machine like I can a Linux machine here, so you could use the Homebrew package manager most likely to install it on Mac OS. So if you head over to homebrew.sh, I think is their website, or it's actually just brew.sh. This is the command line package manager that you can use on Mac OS to install lots of different dev tools. And if we just do a package search here for Lua, it looks like it's actually not there, so it's kind of proving me wrong. Maybe there's a cask for it instead. Doesn't look like it, so in that case, I'd probably just install Docker Desktop on Mac OS, which I already do have on a MacBook Pro actually for my job, and I'd probably just do a Docker container just like I showed you a moment ago on the Linux platform here. So I'm just running Docker on top of the Linux machine, but I also do have it installed natively as well. So right here, I can run Lua, and this is running directly on top of my Linux machine. If I do uname-a, there you go. That is my Linux operating system. So it's Ubuntu Linux, Ubuntu Studio specifically. That's a special distribution of Linux. So in any case, that's how we can get Lua installed. But just having Lua by itself probably is not necessarily the best developer experience. Really, with any programming language, whether it's Rust or PowerShell or C#, or in this case, Lua, it's really helpful to have some developer tools that can kind of help you along so that you don't constantly have to switch out to the documentation for that language in order to understand how the language works. Sometimes it's just nice to have those really quick reminders directly inside of your development tool. And so generally, it's advisable to use Microsoft's Visual Studio Code, which is available over at code.visualstudio.com. Tried to autocomplete it there, but my browser decided to abort the auto completion on me. But if you install Microsoft Visual Studio Code on your development system, it does work cross-platform as well. So just like Lua is cross-platform, you can also install Visual Studio Code cross-platform as well. On the Ubuntu operating system, it's actually really easy to install with the Snap Package Manager. And I know a lot of people don't like the Snap Package Manager, but I actually have a pretty good experience with it. So if we just do a snap list command here, I should have the code package installed right up here, which contains Visual Studio Code. So you can install it using the Snap Package Manager if you'd like, or you can just download the Debian package or the RPM package for your Linux distribution directly from the code.visualstudio.com website. So that's how you can get Visual Studio Code itself installed. But then once you have Visual Studio Code up and running, which I do right here, there's actually an extension or kind of an add-on that you can install into Visual Studio Code that specifically adds support for Lua. There's actually two different extensions that I wanted to point you to. So if I hit Control-Shift-X on my keyboard to go over to the extension marketplace here, if you just do a search for Lua right here, there's a really nice extension. It's very well reviewed called Lua from the user called Sumneko. And as you can see, it's got almost 5 stars there. It's been downloaded over 1 million times. And this gives you auto completion for Lua. You don't really have to configure anything. I just installed it on my Linux dev system here, and it just kind of worked for me automatically. So that was really nice. I'm sure there's probably some configuration options if I went to the VS Code JSON configuration, but you don't really have to. Now, the other thing that I would recommend that you install for extensions is this Code Runner extension. Unfortunately, the Lua extension that I just showed you doesn't support the debugging capability, but if you use the Code Runner extension here, you can actually just do Control-Alt-N on your keyboard, and that will just run the current Lua script that you have open inside of your editor. So I'm going to be, for the rest of this video, relying on the Code Runner extension so that I can just do Control-Alt-N to execute my Lua programs that I'm actually writing inside of Visual Studio Code. All right, so now that we've talked about the development tools, you'll probably want to create a new folder. So I've got this folder open on my system here called Trevor-Lua, and we're just going to create a new Lua script file. So this is a source code file, just like with any other language out there, whether it's Rust or C# or anything like that. And it's just going to have a .lua file extension on it, and you can call the file whatever you want to. So I'm just going to call this Trevor.lua. And then we'll hit Control-B to close that sidebar just to make our screen a little bit cleaner. And now we can go ahead and start actually writing some code. So I did want to show you how to run things interactively really quick and some challenges that you might come across when you're using interactive Lua. So what I'm going to do is actually switch over to the terminal here. And we could also use the integrated terminal in VS Code if we wanted to, but I'm just going to use a dedicated terminal right here, which is the console terminal with a K. And so now, inside of this Lua REPL, read, evaluate, print loop, we can go ahead and just start running Lua commands. So we could do something like 1 + 1, and that will result in 2, right? We can also do something like 3 - 2, that'll give us 1. So we can do these mathematical operations. We can really type any type of Lua statement that we want to in here. We could also write if statements if we wanted to. This isn't necessarily the best experience if you are writing a lot of complex code, but if you're just really quickly trying to test out an expression to see if it works or not, then, this could potentially work fine for you. Now, one of the challenges with Lua comes to the variable scope. So there's local variables and there are global variables. If you define a local variable inside of, let's say, a function scope, for example, so if I'm writing a function, we'll talk more about functions later, but if I create a function here called do stuff, and then inside of this function, I declare a variable like local a equals 1, and then end that function, this a variable is restricted to the do stuff scope. If I try to look at a here, you can see that it's nil, which basically means that it's a null value. It doesn't exist. But inside of the do stuff function, which I can call right here, it does actually exist. And I didn't actually print out the value in the function there, but when I call that function, that local variable gets defined inside of the function's scope and is accessible to any additional statements that follow the variable definition. Now, inside of the REPL here, you might say, all right, well, I'm just going to declare a local variable like name. So I'll say local name equals Trevor. And now you might think, well, I'm just going to use the print function here. We're going to make very liberal use of the print function just to print stuff out to the terminal. You could also in the future interact with files or remote APIs or things like that if you want to, but we're just going to make very good use of the print function here to just print out data locally into our terminal as we're practicing. And now you might type print name and you might see nil here. And you're like, well, I defined this local variable and I tried to print it out, but it returned nil. So what happened here? Well, this is one of the issues that I came across when I first started taking a look at Lua. And what's happening here is that the local name declaration here, the variable declaration here, is actually getting put into its own child block. So even though we're typing it into the REPL, it's actually getting kind of wrapped into its own block. And then once that block returns and we type another statement into Lua, that variable just is no longer defined. So you can't really just go define local variables here. What you need to do is define a global variable, in which case we just leave the local keyword off and we say name equals Trevor. And then if we do a print name here, we now get the value that was stored inside of that name variable. So there's really two variable scopes that you'll want to be thinking about. We've got the local scope, which we explicitly use the local keyword to specify. And then we also have the global scope. Now, something else that's interesting here is that if you want to use a local variable, you can actually specify on a single line multiple statements. So if I wanted this local name statement to work here and then be able to print it out, I can just put a semicolon after that initial statement and then do print name after that. And that is going to wrap both of those statements into the same block so that the print statement over here will actually have access to the local variable right here. And you might be looking at this and think, well, no, it's actually just referencing the global variable because I defined it up here. Well, just to prove that, I'm going to change the name variable here locally to Trevor Sullivan. And when we do print name, sure enough, you can see it prints out Trevor Sullivan here. So as long as we put things on one line and use a semicolon as the line terminator or the statement terminator, we can actually have multiple statements on a single line. Something else that we can do is actually be more explicit with our block definitions. So one of the things that Lua supports is the ability to create a block by using do end. So we start off the block with a do statement here, and we can just say local last name equals Sullivan. And then you see we have these double carets here. That indicates that we're still inside of the child block that we started defining with do here. It doesn't actually close off this block until we do end, right? The actual literal end. So if we do print last name and then type end here to close off the block, that block of code will get executed by the Lua interpreter here, and you can see we get back Sullivan. But if I just try to do a print last name, you'll see that that last name variable that was previously local is now once again out of scope. So when you're dealing with the REPL, you can't define local variables at the global level and expect them to be persisted because they are getting wrapped inside of their own child blocks. So just be aware of that as you're dealing with the REPL. So that's why it's often better to just use a editor like Microsoft Visual Studio Code, where you can write all of your statements inside of a Lua file, and then you can use the Lua CLI to actually execute that file all at once rather than using the REPL interface. So over here in Visual Studio Code, we'll go ahead and just create a local variable, very similar to what we just did. We'll do local last name equals Sullivan. We'll do print last name here. And you can see I'm getting this auto completion. All of this auto completion is coming from that Lua extension that I installed into my Microsoft Visual Studio Code environment. And so the extension knows that I've declared this variable or defined this variable called last name. And so it's going to auto-complete that variable name for me because it knows that it exists. I can also hover over that and I can see that it's a local variable. I can also see the value. So if I was, maybe scrolling down a couple hundred lines inside of a massive source code file, I don't have to scroll up and search for the line that actually declares that variable because I can just hover over it and I can actually see what its current value is set to. So that's one of the great things about using these developer tools like VSCode and the various extensions for VS Code for each corresponding language. So now that we've declared this script here, what we can do is, remember I showed you that Code Runner extension? So if we hit F1 to open up the VS Code command palette here, and let's say run code here, this run code command that you see right here, Control Alt N, is the default keyboard shortcut for it. We can go ahead and just hit Control Alt N with this trevor.lua file open right here, and it'll go ahead and execute that down here under the output section. So it should say output, and then in this drop down right here, you should have the code thing selected. That's the Code Runner extension. And so now you can see that it actually executed the Lua CLI command, and then it passed in the file system path starting at the root of the file system, which is just the /. So it drilled down under the folder structure down to where that source code file is, and it executed it, and this is the result that was returned from the script. And just to prove that to you, if I change this to something like Sullivan22222 and rerun that once again, let's scroll down to the very end here of the output, you can see it printed this out. Now, something that can frequently happen with this extension is that this little auto-scrolling feature will get turned off here. So if you see that the lock is open, that means that auto-scrolling is off. That's why I had to manually scroll with my mouse wheel. But if you just click on that button to turn auto-scrolling on, then it should, let's just change this value here, do Control Alt N again, and you can see it automatically scrolled to the very end here. All right, so this is how we can start to develop Lua scripts inside of Microsoft Visual Studio Code. Now, there's a few different data types that you'll want to be familiar with. One of those is nil. So nil is kind of like a null value or an empty value. It just doesn't exist. So we can still declare a variable with a particular name. We just set the value of that variable to nil. And so if we try to print this out right here, whoops, you got to make sure you don't have any code selected, because if you do Control Alt N, it'll only execute the code that you actually have selected. So I'm just going to hit escape to make sure I don't have any code selected. And then we'll do Control Alt N, and you can see we just get back nil. So nil is what can happen if you have a variable that's undefined, for example, and if a variable's empty, things like that, then you'll oftentimes get back a nil type here. We also have the support for Booleans like true and false. So we could say print true, and these are case sensitive. So I can't do like a capital T for true because it'll think that I'm referencing a variable here, which I'm not. So we need to make sure that Boolean values, when they're being referenced, are lowercase. So we have lowercase true and lowercase false as well. And so that'll just print out the string representation for true or false. Just do Control Alt Shift N down arrow to copy that, do print true, and if we do Control Alt N to execute that, see, auto scrolling got turned off again automatically for me there, but you can see it prints out false and true. Now, one other thing I meant to mention as we were talking about variables is the difference between locally and globally scoped variables as far as the naming convention goes. Now, you may have noticed that when I declared this capital T true here, that it says undefined global true. And that is because in Lua convention, a global variable should start with a capital letter. That's not mandatory. I can have global variables that start with a lowercase letter, but by convention, it does expect that globally scoped variables are going to have a capital letter instead. So the reason that we get this message from our linter here, or the Lua extension for VS Code, is because it thinks that because this is not a valid Boolean value, it thinks that this is actually a reference to some variable that we're trying to define. So what we could do is come up here at the top and say true equals Trevor, right? And so now we've declared a variable with the name true because the Boolean value is lowercase t, so we can actually declare a variable with a capital T true. And now this is a globally scoped variable because we have not specified the local keyword here like we did for the last name variable. And so now that message goes away because we actually have declared the true variable up here. And so now if we hit escape and run our script again, you can see that it prints out Trevor down here because that is the value of this globally scoped variable. So as you are declaring variables, let's say like first name equals Trevor, you can see that we're going to get this little warning here, this little blue squiggly line, and then the message in the editor here says global variables in lowercase initial, basically saying, did you mean to make this a local variable? Because I noticed that your first character is lowercase. And so if your intent was not to have it be local, then by convention, we just make that a capital character. And that's how we, by convention, define global variables. So that's just kind of good practice when it comes to Lua code, is just to follow the recommendations of the linter that Lua provides. All right, so that's some basics about variables and variable scope and variable naming. Let's go back to data types. So we've got nil, we've got string data types here as well. We can also use single quotes here as well. So single quotes will allow us to define a string. That works perfectly fine, just like the double quotes did as well. And we also have a number data type. We also looked at true and false. We also have a number data type, so we could say local age equals 35. And then down here, we could say print age, and Lua will automatically interpret the number as a string value here for us. There is also a toString function, so if you want to be a little bit more explicit about it, you can call the toString global function here and then pass in the age number value here, and that will allow you to just interpret it a little bit more explicitly. And of course, I keep selecting code there, so the reason we get these compilation errors is because I am just selecting a portion of the code, and that's not valid. We have to run the entire script here. So there we go. So toString age is just resulting in a string 35. Now, with numeric values, we can do addition, subtraction, multiplication, division. We can do powers as well. And so if I wanted to say age equals 35, I could do another line. If I wanted to add to the age, I could say, all right, age equals age plus 3. All right, so age will be reassigned here from 35 to now 38. So when we print it out on line number 9 down here, that variable has been mutated from its original value of 35 to now be 38. And because that was declared as a local variable, Lua is not creating a new global variable. It's just interpreting our existing lowercase age local variable that we've already defined right here. All right, so that's the number data type. We could also do subtraction here, so let's just try that really quick. So 35 minus 3 should be 32. Sure enough, we get that. But what happens if we try to use an addition to a string? What if we try to do Trevor plus Sullivan, right? And so we've got this global variable called true. That's really confusing. Let's call it full name here instead. I'll actually show you something that's really cool in the VS Code editor. So if I ever want to rename this variable called true right here, I would normally have to reference this in multiple places, right? I'd have to change it right here on line number 3. I'd have to change it on line number 8 as well. But there is a function in VS Code. If I do F1 or Control-Shift-P in the command palette, there's this rename symbol capability here. And so what you can do is say F2 to rename, and then I can just rename this one time to something like full name, and that will automatically update the other references to that variable. So if I had like 10 or 20 different references inside of the source code file, I don't have to go manually update all of those. I can just use rename symbol, and the editor will intelligently go find all the references to it and update those names based on the new name of that variable that I have specified. So that's a really nice feature for VS Code and many other text editors out there as well. All right, so now if I change full name here to Trevor plus Sullivan, let's go ahead and try to run that and see if it works. And unfortunately, it doesn't. So basically, it's saying that we get an error when we attempt to add a string with a string. And in some other programming languages, like I'm pretty sure this works just fine in PowerShell, but if I try to concatenate two strings together by using a plus sign, it oftentimes will work, depending on what language you're dealing with. I think even Python might support string concatenation with a plus sign as well. I'd have to go actually test that out to verify it. But what we can do instead, if we want to achieve a string concatenation, there's actually a special operator that you can use called the double dots here. I don't actually know if that's what it's called, but this is the string concatenation here. And so when we, let's put a space after Trevor there. When we use these double dots, it's basically going to take whatever's on the left-hand side and whatever's on the right-hand side, and it's going to simply join those together. So now, if we try to run this entire file, once again, you can see that this works perfectly fine. We print out that full name variable, and it's Trevor space Sullivan. I could just change this first name here to something else, like Joe, for example, and that's going to work just fine. So this 2 periods here are going to allow you to concatenate strings together. So we could even do something like dot dot space is age. And I'm actually going to move this down a couple lines. So we'll declare age as a variable first, and then we'll append is age, and then we'll do dot dot again. And we're actually going to append this numeric value to our string. So we'll put age at the end. So now we've just kind of combined all these different strings together, and we've actually added a variable here at the end. Also, I could take this first name and I could just put it here instead. So let's do first name. And now it's going to reference whatever we have stored in this global first name variable, and it's going to substitute it right here. And I also want to put a space there at the end so it doesn't butt up against the last name. So now if we do Control-Alt-N, go ahead and run that. Now you can see it says Trevor Sullivan is age 32. And so that's how we can concatenate these string and, for that matter, number values into a much larger string. And then we ultimately took that concatenation and we assigned it to a new variable. So now this full name variable actually contains that entire string, right? All right, now another very common thing that you'll do is deal with multi-line strings. So this is just kind of a single line string, right? All the text just appears on a single line. But sometimes you'll actually want to have strings that span multiple lines. Maybe you're dealing with a paragraph. Maybe you are printing out a table of data and you want to format that table of data using, dashes and different types of characters to delimit the different fields of data inside of the table. So I'm going to go ahead and just eliminate that so it's not so busy. And let's talk about multi-line strings. So there is another special syntax that we can use that is double open brackets. So these are square brackets, right? So we've got things like curly braces. We've got things like parentheses. Some people call parentheses brackets, and that kind of bugs me. But when we talk about brackets, we're oftentimes talking about these squared off brackets, right? We're not talking about curly braces. We're not talking about parentheses. We're talking about the square brackets here. Now, when you have 2 opening square brackets and 2 closing square brackets, that denotes a multi-line string. So I don't have to use quotes in this particular case because these are replacing essentially our quotes as far as multi-line strings go. So I could literally just put some text inside of here and assign that to a variable. So let's do a local variable called first name and set it equal to this expression that we have right over here. So this is technically a multi-line string, even though it's not actually multiple lines. This is just another way for us to define a string if we have multiple lines. So now I could just print this out, and this isn't really going to do anything special here because it's over a single line. But if I put a literal new line inside of my source code file here, and then type Sullivan there, well, that new line character is actually going to be interpreted by Lua when we run our Lua script here. And so now we have Trevor and then a new line character and Sullivan on the next line. So that's how you can do multi-line strings. And these also support concatenation, just like regular strings do with double or single quotes. So if we wanted to, we could put a space here at the end and say is age space, and then do dot dot age. And then let's go ahead and define the age variable. So we'll do local age equals 35. And if we go ahead and do Control-Alt-N to run that, you can see that this multi-line string here is concatenated with the double dots, double periods, just like the other regular strings that use quotes. So we could mix and match this. And if I wanted to put a literal period at the end of this sentence right here, I could just do another string concatenation here with the double periods and then put a period at the end in double quotes or single quotes for that matter. And now we should have a period at the end of our very simple sentence right here that spans multiple lines. Now you can also use multi-line strings together in multiple sequences. So if I wanted to, let's say, put this period inside of another multi-line string, I could literally just do a multi-line string with a period inside of it, and that's going to work exactly the same way as putting the period inside of quotes. And then if I wanted to keep adding on more lines, I could say, and Sherry is new line, age 39, period. Okay. So I know the syntax probably looks really bizarre here, but once you understand that these double square brackets to open and close are just representing a multi-line string, you can actually break it down into components. So there's one, there's a variable reference, there's a second multi-line string, and anytime that you see the double dots, that's going to reference a string concatenation in the Lua language. So that's a really nice capability that we have. Also, I did want to mention how we can add comments into our Lua program. So one way to do that is to use a double dash here. This is very similar to the SQL language. So when you're writing SQL scripts in, MySQL or Microsoft SQL Server, that kind of thing, you can actually just use a double dash here and say, this is a comment. We are learning about strings. We could come down here, do a double dash and say, this is a print statement. We can save that, run it, and any lines in our Lua file here that have a double dash at the beginning are ultimately going to get ignored. Now, very similar to the multi-line string syntax that we have right here, we can actually have multi-line comments as well. So it looks very similar to a multi-line string, with the difference being that we actually have the double dashes prefixing the square brackets that we have, right? So we could have a multi-line string like, this is an awesome comment. Now this right here is a multi-line string, but if we put double dashes at the beginning of it, that actually turns it into a multi-line comment. All right, so now you can see that this entire block that we have right here is now being considered a comment. You can see it's highlighted differently in the text editor. And if we run our Lua script right here, you can see, sure enough, we get the same result here. So we have single line comments where we have just two dashes, and then we have dash dash with the multi-line string syntax in order to have a multi-line comment instead of a multi-line string. All right, one other data type that I wanted to point you to, oftentimes there is support for things like arrays or dictionaries inside of many programming languages, and Lua actually supports a similar notion. They actually call them tables. So there isn't an array data type, there's not a dictionary or hash table or hash map data type or a set data type that has just unique values like many other programming languages have. But there is the ability to create something called a table, and a table can have an array of items, and it can actually act as a dictionary where you can have an item property, a property name, like first name equals Trevor, right? Or last name equals Sullivan, or age equals 35. So let's take a look at the table data type to better understand how that works. So tables are going to use curly braces. So we're just going to eliminate all this code, and we're going to start with a couple of curly braces right here. We actually only want one pair. My brain is still thinking about multi-line strings, I guess. And so what we could do is say a variable like local foods equals these curly braces. Now, something else when it comes to data types like strings, numbers, booleans, nil values, tables, things like that, there's actually a function that can help us figure out what data type is inside of a variable. So in this case, we have a local variable called foods, and based on these curly braces, it has an empty table. So it's a table data structure, but we don't have any items. It's not an array. It doesn't have any key value pairs or anything of that nature, right? So what we can do, oops, accidentally deleted those. So what we can do is actually print out not the foods variable itself, but we could actually print out the result of the type function here. So the type function actually returns a string that represents the data type of the variable that was fed into the function call. So if I could do a local variable here called foods type and assign that to the result of type foods, and then if I print out foods type, it's going to have a string that says table, and it'll also tell me where in memory. So I think it returns the memory address, at least in some cases. But in this case, the data type is just table. Actually, it prints out the memory address if I just print out foods itself, I think. So let me try printing out foods. And yeah, now it tells me it's a table and the specific memory address. But as far as the actual data type, it's just a table, right? So what we can do is actually create conditional statements to say if this foods variable is a table data type, then we want to run a certain set of code. But if it's a string value, then we want to run a different set of code, right? So maybe instead of having an array of elements here, like orange, bacon, steak, burger, things like this. This is how we define an array of elements inside of a table. So this is the same as what we had before, but now rather than having an empty table, we have a table with 4 elements. In most other languages, this would be called an array, and these tables are actually 1-based. They're not 0-based as they are in many other languages. So in order to reference a specific item from this table, or I like to think of it as an array, even though it's technically called a table in Lua terminology, is we could actually use square brackets here to index into a specific item. So if we use the 1 identifier, because again, it's not 0-based, it's 1-based. So 1 is going to refer to the first element of the table. So if we do Control-Alt-N here to run this code file, we get orange. If we do 2, we should get bacon, right? So there's bacon and so on and so forth. Now we can't do something like 5 because we only have 4 elements in the table, right? So if we specify 5, we actually get nil back. So if you are looking at a table, if you're inspecting a table and you're grabbing a specific index of an item in that, and you get back nil, that could potentially mean that there's not that many items in the table, but it could also mean that nil is actually one of the values in the table. So you can actually mix and match data types in these tables here. So in this case, I have mostly strings, but now I just added a nil value into my table. So if I print out foods and go get the second item from the foods variable table, you can see that I get back nil here. All right, something else that I wanted to talk about, I think I may have skipped over this, is the length operator. So if we want to get the length of let's say a string, for example, we can actually use something called the hash sign or pound sign here, depending on what your preference is. So the pound sign is a way to get the length of something. So let's go back really quickly and say local food equals orange. All right, let's say I want to figure out the length of this orange here. So what I'll do is say print pound food, okay? And what do you think that's going to return? Well, if you said 6, then you would be correct. It prints out 6 because that's the length of orange. If I change this to bacon and rerun this again, you can see now it is a length of 5. And I'm pretty sure that also works on table types here too. So right now we have 5 elements in the table. So if we do pound foods here, instead of just printing out the table itself with the memory address, we can do print pound foods. And now you can see that we've got 5 elements in the table. So if you're trying to figure out how many elements are there in this table, then just put the pound sign in front of that, and that'll tell you the number of items in the table, or in the case of a string data type, the actual length of a string. So that's something that's kind of nice to deal with there. If I take nil out and we go back to our foods right here, you can see that the length of our table went from 5 down to 4 right here, thanks to that pound sign that's telling us the length of the table. Now, tables can also have references, like key value pair references. So I could have like fav01 equal to burger, right? And so now down here, I could actually say foods dot fave01, and that's actually going to reference this dictionary item. So it'll look up, all right, I want fave01, and then get the value for that, and it should be burger, right? So there's burger. And so now I could add another key value pair that says fave02 equals bacon. And so if I run this script, now I still get burger here, but I could do Control-Alt-Shift down arrow to duplicate that and print out whatever is in fave02. And so now Lua will do a lookup against this table. It'll look for fave02, and it should print out burger followed by bacon. So the curly braces here for table definitions in Lua allow you to specify arrays as well as what would often be known as dictionaries or hash tables or hash maps, which is basically the same terminology for this key value pair setup that we have here. But in Lua, we just call them tables, right? So if we take a look at the type, if we print out the foods data type here that we get using the type function, it's still going to be a table, even though we turned it from an array into a kind of dictionary type of data structure. All right, so that is something that's interesting about tables. They work as arrays and they work as dictionaries. Now there's one other thing when it comes to variable naming. I'm going to kind of go back to talking about like global versus local variables and that kind of thing. So we talked about how lowercase names for variables are generally going to be for locals, and uppercase names for variables are going to be for globals. That's just a convention. It's not enforced by the actual language itself. But something else to note about variable names is that you cannot actually start a variable with a number, because otherwise Lua is going to attempt to interpret that variable name as a literal number, and that will actually break the parser, and so it won't allow you to run the code. So if I try to do local 2s equals Trevor, you can see that the linter here inside of the editor, even though we haven't executed the code yet, it's expecting there to be a variable name right there. But instead, it sees a number at the beginning. So if I hit Control-Alt-N to try to run this, you're going to see that we just get this error message that says malformed number near 2s, because it starts to interpret the number 2 as a literal number. And then when it sees the S directly following that, it thinks that that is just a malformed number, because an S has no meaning as far as a number goes, unless of course you were to, convert it to a byte using an ASCII lookup table or something like that. But it's not going to infer that type of thing. You'd have to explicitly do that if that's what you're trying to accomplish. So as far as variable names go, you cannot start with a number, but you can start with a letter and then have a number somewhere later on in the name. So S2 is a valid name for a variable, but 2S or 2A or anything like that is not going to be a correct name or identifier for a variable. All right. We did already talk a little bit about math. So we did in the REPL, we did things like 3 minus 2. So we could assign that to a variable like result. So we'll do a local result variable and then say print result. And we should just get 1. 3 minus 2 is 1. We can also do addition. We can do division. So if we do 3 divided by 2, of course, that is not going to do even division there. It's not like 4 divided by 2 is going to give us a whole number like 2. So in that case, we get 1.5, which is the correct output. We could also do something like 13 divided by 2, and we should get some other kind of bizarre number like 6.5 right there. So that's how we can do division. And then I think we can also do powers with the caret operator here. So if we say like 3 squared, we should get 9. So let's go ahead and run that. Sure enough, we get 9.0. If we do something like 4 squared, that should give us 16. So sure enough, there's 16. So that's how we can do a power operation and exponent. If we do 4 cubed, for example, then we should get 1664, I think would be the correct number. Sure enough, there is 64. Now, there is actually a module. We'll talk a little bit more about modules a little bit later on, but there is something known as a math module that's built in directly to Lua. And if we head over to the documentation for Lua right here, and scroll down past these chapters right here, you'll see under the index right here, we've got Lua functions. So you'll see right here under this column, we've got math, math.abs, that's short for absolute value. We've got the a cosine, a sine, a tangent, ceiling, floor, exponent, logarithms, things like that. So there's a lot of different math functions available on this math module. There's also other modules that are built directly into Lua that you don't have to explicitly import. They're just automatically available. We're going to talk again about modules a little bit more later on, but there are built-in modules called OS, debug, coroutine, package, string, IO, table. There's even one here called UTF-8 as well. So just be aware that these do exist in there. So as far as doing math goes, we can use the standard operators like plus, minus, multiply, asterisk for multiply, forward slash for divide, and then the caret character, shift 6 on your keyboard to do a power operation. But we also, where was I going with that? We also have the ability to go into this math module right here. So if you just type math dot, now you should see all these different functions that are provided by this math module. So if we wanted to, we could do something like, let's do -4 times 3. So when we multiply a negative number by a positive number, we should get a negative number, right? So -4 times 3 is -12. Now, if we wanted to get the absolute value of that, we could create another variable here called result abs equals math.abs of result. So result contains -12, but if we take a look at result abs, we get the absolute value. So it's always going to be positive, right? So if we pass in a negative number, it's just going to turn it into a positive number. So we get positive 12. If we do 4 times 3 and have positive 12 and get the absolute value of positive 12, well, it's still going to be positive because absolute value always gives us a positive value. We can also do things like math.ceiling and math.floor. So those are rounding operations. There isn't a built-in round operation, I don't believe, unfortunately. So you can't just do like math.round. I think some other languages out there support that kind of thing. I think maybe PowerShell has a .NET namespace that can do math stuff, and I think they have math rounding in there if I recall correctly. But if we do something like, let's say 5 divided by 3, right, that's going to give us a weird number, like a fractional number like 1.66666666 infinitely, because we basically have 2/3 remaining. So what we can do in that case is get the ceiling. Let's do result ceil, and let's actually use our F2 rename symbol. So we'll do result ceil, and then we can do math.ceil, and that will give us the smallest integral value larger than or equal to x. And so that should give us, I believe, 2. So sure enough, the ceiling of 1.66666 infinitely repeating is going to be 2. If we do math.floor, that's going to give us the smallest integral value, or the integral value smaller than or equal to x, as you can see right there. So if I just rename this variable, just for the sake of readability, to result underscore floor instead, and run that, now you can see that we get back 1. So you can round up or round down, but you unfortunately cannot round based on the actual decimal value, but you can, implement that yourself relatively easily. Now, there's lots of other capabilities inside of the math module for Lua. For example, if you want to get a random value, there is something called math.random. So if we do math.random right here, we can say, just give me a random value. Now, what you're going to notice is that every time that we run random, so we get 6.33 or 0.6331, right? And then let's just clear that and try to run it again. And now we get 0.8433, okay? try to run it again, 0.122, right? So we get these random values. But something else that we can do, if we check out the documentation here, is to specify a random seed value. And so when we specify a random seed value, we can actually increase the randomness of the random number generator. So what we could do is say something like math.random seed and set it to something like 1. And so as long as we have that same seed, we'll always get predictable random numbers. So now if we run this, we get 0.81558. And if we run it again, we get the exact same number. So as long as we have the same seed, we're always going to get the same first random number there. If we change it from 1 to 2, now we start to get a different number. But if we run it again with the same random seed, then we're still going to get the same random number. So if you want some somewhat better randomization, it's not perfect randomization, but what we can do is actually reach into the OS module down here. And we have this function called os.time here. And os.time is going to give us the number of seconds from the epoch. And so what we can do is just set the random seed to os.time, and every second, that's going to be a new number. So if we call this, we get 0.0248. If we wait a second and call it again, we should get something different, like 0.0401, right? So this is a nice way to just very easily add some randomization to your Lua program if that's what you are attempting to do. Also, we've got things like math, max, and min. So if we need to get a maximum value from an array, or again, it's called a table, not an array, but if we want to get a max number here, we can just call either min or max. And so let's see, where's max? There's min, here's max. And so when you see these triple dots right here, that means that you can have kind of a unknown number of inputs to your function here. So if we do, let's say math dot max, it's not actually going to be a table. I misspoke there. What it's going to be is it's going to be multiple arguments here. So what we'll do is say local max equals max of that. And then we'll say local min equals math.min of, let's just choose some random numbers here. Just going to type some random numbers in there. And so our minimum value here should be 34, right? Because out of these four numbers, 34 is going to be the smallest in here. And then right here, 1, 2, 3, and 4, of course, the max is going to be 4. Or if we add, a 9 somewhere in the middle, then 9 is going to be the maximum value. So we'll just do print max, duplicate that down, and say print min as well. And so from this list right here, our minimum is 34. From this list up here, our maximum is the number 9, which is what we get right down there. So that's a couple of other mathematical functions that we can use inside of that math module. Now, let's talk a little bit more about strings. So we've already talked about how to concatenate strings, right? So we have the ability to use a double dot to concatenate a couple of values. Let's do local first name and local last name as a couple of variables. Then we can do local full name equals first name dot dot, and then we'll do a literal space there, and then dot dot, and we'll do last name, right? So now if we print out full name, we should have Trevor space Sullivan. Right, so we've already talked about that. We also talked about how to get the length of a string. So if we want the length of full name right here, we can always do the # right there. And so the length of Trevor Sullivan with a space is 15 characters. And then we can also do things like string operations. So there's actually a string module back over here in the Lua documentation. If we scroll down a little bit here, you can see that there's a string module, just like the math module that we just talked about. And this actually allows us to do a lot of different things with strings. So, for example, one of the common things that you'll want to do with string values in any programming language is to get a substring from a larger string. So, if I have a string that's 15 characters long, maybe I want to go inside of that string somewhere and grab 3 characters or 10 characters, right? So, what we can do is use the string.sub function here to specify an input string and then specify the number of items or characters that we want to retrieve from the string. So if I wanted to take this full name here, Trevor Space Sullivan, and grab the first 6 characters, which would be my first name, then we can say print string dot sub, and then we'll pass in full name because that's the string that we want to basically carve up into something smaller. And then I'll specify an integer that specifies how many characters I want to pull from that string. So now line number 6, it's actually going to skip over that number. So you can see it actually skips over a bunch there. So that wasn't quite what I expected. I actually thought it was going to grab the first set. So let's just read the documentation here. So returns a substring of S that starts at I. Okay, so that was my bad. So it actually starts at the character that I specified there. So it's actually starting at character number 6, which is going to be R. And then it basically just grabs the rest of the string. So what we can do is say until J. So we can say, I want to start at whatever I is, that's the middle parameter, and then go until J. So if I wanted to grab 3 characters, I could say, all right, I want to start at character number 4 and go up to number 6, right? And so we would do 4 and 6 there. So let's do 4 to 6. And that should give me VOR. So we start at the 4th character and go up to the 6th character, and that's inclusive, basically meaning that it's including the character number that we told it to end at. It's not excluding it. Some languages are exclusive in that sort of thing, where it would basically say, I'm going to go up to 6, but not include 6, the 6th character here. So you can do things like that. So if I wanted to start at 1 and go up to 6, that should give me what I was originally expecting, which is my first name here, and I could say, all right, go up to the 8th character, and that should grab Trevor space S. So that's 8 characters long right there. So you can use sub to basically grab certain characters. I could say start from 6 and go to 8, and that'll give me the R at the end of my first name, the space, and the capital S from my last name. So it's basically giving me the last character here with a space and the first character of my last name, which of course are these values that we have right up here. Now there's also a bunch of other functions in the string module here. So we have string match, right? And this is going to look for a certain pattern. We've also got things like string find. So if we scroll up a little bit here, string.find, it's going to look for the first match of a pattern. And if it finds a match, then it's going to return the indexes where it was found, where it starts and ends. So let's say that I wanted to search the full name string and see where Sullivan actually starts. So what we'll do is say print string dot find, and then we want to find inside of the full name variable right here. And the pattern that we're looking for is going to be Sullivan, just a literal string Sullivan. And so if we run this here and take a look at the result, you can see that it tells us the indexes of the characters in that string where Sullivan starts and ends. So it starts at character number 8, which is the capital S right here, and the N at the end of Sullivan is the 15th character in the string. So if I just change the variable for first name to something like Sally instead and rerun this, now the find function right here is looking for Sullivan again, but because Sally is shorter than Trevor, now Sullivan actually starts at character number 7 and it goes up to character number 14. So that's kind of how things work from the find operation right here. All right. Now, one thing you're probably going to notice right here, we'll talk a little bit more about this later on when we talk about functions, but you'll notice that we actually got two different values here. So functions in Lua can actually return multiple values. It's not restricted to just returning a singular value. You can return multiple distinct values. So you could return a string and a number, or a string and two numbers, or two numbers and two strings, or any kind of combination like that. Or if you wanted to, you could actually wrap all of those up into a table construct and just return the entire table. But functions do allow you to return either nothing, singular values, or multiple values. So just be aware of that. And I will actually really quickly show you how that works. So in string.find here, what we want to do is capture the starting character. So let's call that local start car. And then we'll call the ending end car. And we'll make those both local variables here. So now when we call the string.find function right here, it's going to return the first value, which is this number 7 right here, into this variable called start car. And then it's going to return the second value, the second numeric value here, and assign that to the end car variable. So now what we could do is print out a multi-line string. Let's do local results, and we'll create a multi-line string that says the string was found starting at character number. We'll put a space there, and we'll do ... and say start car ... and then we'll do another multi-line string, and the ending character was found at, and then we'll do a space ... and say end care. And I'm just going to put a new line here rather than a space so that we can split this little paragraph here across two different lines. All right, so let's go ahead and run this and see what we get back. And of course, I need to print that as well. So let's say print results. Let's go ahead and run that again. And now we have this nice little sentence here that says the string was found. So of course, the string being Sullivan, we were searching for Sullivan inside of full name, and it was found starting at 7, and the ending character was found at character number 14. All right, so that is how we can use the multiple results from the find function here. All right, something else that I wanted to talk about are just really quickly the blocks that we talked about in the REPL. So if you recall in the REPL where we assigned a local variable and then we tried to print out that local variable, that variable had already gone out of scope because it was being kind of wrapped in a block, so to speak. So inside of a script here, we can just do end, and anything that we put inside of this block here is going to be restricted to that scope. So if I do local first name equals Trevor, and I say print first name, well, the block is going to automatically get executed. It's not like a function where you have to explicitly call the function. So you declare the function, and then you can call the function as many times as you want to. A block is just automatically going to get executed. But if we try to duplicate this print statement here and try to print first name outside of the block, you're going to notice that we actually get this error here. So not only do we get an error from the linter, because the linter knows that we don't have a global variable named first name, but it actually just prints out nil because that variable just doesn't exist. So we therefore get nil instead. So this is how you just declare kind of a child block. And then again, any variables defined as locals inside of that block will be restricted just to that block. But if we take out the local keyword, now first name actually becomes a global variable. So even though we're in this child block, because we're now declaring a global variable instead of a local variable, now the print statement on line number 5 that's outside of this code block right here actually has the ability to reference that global variable. So now if we run this, we actually have the ability to reference the global variable from inside the block but we also have the ability to access the global variable from outside of this child block. But when we make it a local variable, then only the statements inside of the block have access to that local variable. So just be thinking about the scope of your variables when you're accessing those variables. And again, the linter will kind of help you out. So if we have a local variable, it knows that on line number 5 that this variable has gone out of scope. So it's going to throw this warning here. It'll still let us run the code. It's not going to panic or anything like that or throw an error from the Lua executor, but it is going to warn us as far as the linting rules go, just to let you know that, hey, you're actually trying to reference a variable that doesn't really exist. All right, so now let's talk about modules. We've talked a little bit about these. Let's actually do functions really quick. I think before we do modules, we need to talk about functions. All right, so what we're going to do is go ahead and actually define a function. And to do that, we use the function keyword here. And we can give a function a name, just like in other languages like JavaScript or PowerShell or Python. We can give a function a name. And to do that, we use the function keyword. In Python, you would use def to define a function. In PowerShell, you also use the function keyword. A lot of languages will use the function keyword. Rust, for example, uses the fn keyword rather than having to spell out function, which makes the code look a lot more concise. But in this case, we can do a function here that's called, let's say, do stuff. For example, we use the open and close parentheses, as is very common in most languages, to specify our input arguments to the function. And then you'll see that we have this error that's occurring here. It says missed symbol end. So all we do is say end for the closing of the function. Just like we had do end for a child block of code in our Lua script, we just use function and end to define a block for a function. So now inside of here, we'll say print hello. And if we save this and try to run it with Control-Alt-N to invoke it, we don't get anything, right? Because when you declare a function, the function has to be called in order for you to actually use the function, right? You can define as many functions as you want to, but if you don't actually call the function, then the function never gets used, right? So somewhere after we've defined the function, we have to actually call the function do stuff. And we do that by just calling the function name followed by these parentheses here. If we don't have these parentheses, then we are actually referencing the function itself. We're not actually calling the function. So what we want to do is specify those parentheses. And now when we hit it or run it, we get hello printed out because we're actually calling the function. Now, order of operations is important. So if I tried to put this do stuff up here before we actually declared this function, then you're going to see this error message appear down here because it says attempt to call a nil value. So this do stuff reference here on line number 1 is actually referencing nil because this function has not yet been defined. So we have to make sure that our functions are being defined in our code before we actually are attempting to call those functions, right? So we also have the ability to use the local keyword on functions, just like we do with variables. They act very similar to each other. So if we just do a local function do stuff here and try to run this, that'll work just perfectly fine right there. Local functions are important when it comes to modules because you can actually have functions that are local to modules that you're not actually exporting from a module. So it allows you to define the scope of a function just like you can with variables. And the same naming convention applies. So if we have a function with a lowercase capital or a lowercase letter to lead it off with, then you'll notice that it's going to complain. The linter is going to complain. The code still works, but by convention, a global function should have a capital letter at the beginning. And then, of course, we have to fix that reference down here because we changed the name. It is case sensitive. Lua is a case sensitive language. So if we name a function with a capital letter, then we also have to call the function with the capital letter as well. All right, so now let's talk about function arguments. So we can pass in arguments to the function. So we could do something like, let's say, pass in first name. And then we could use our concatenation here. So we'll put a space at the end of hello, and then do a dot dot and pass in first name. So now any value that we pass in between these parentheses here, like Trevor, is going to actually substitute that for this argument right here. And then we can reference that argument anywhere inside the function body, right? But if I try to print out first name outside of the function definition, you can see that that is undefined, right? Because the first name argument is only valid inside of the function scope. Now, functions can also call other functions, and the same order of operations is required. You have to define a function before you can actually call a function. So let's say that I wanted to write another function like get age. Okay. And from this function here, I'm just going to say print your age is 35. Now, in this do stuff function here, I'm going to call the getAge function, okay? So I have two function definitions. I declare this getAge function, then I declare the do stuff function. Then I invoke or call the do stuff function right down here on line number 10. Then it'll print this statement first, and then logically the next step is to call the getAge function, which was declared up here, and it should print this line right here. So let's test that out. Do Control-Alt-N. Sure enough, hello, Trevor, your age is 35. But what would happen if I tried to change the order of things here, where I declare a function right here called doStuff that depends on a function that has not yet been defined, right? This function is defined after the function that actually references it. So in this case, if we try to run this here, it still works okay because we're not actually calling doStuff until after we've defined its dependency. But if we try to call doStuff that references getAge, but getAge isn't defined until even further down after we try to call doStuff, then we should end up getting a very similar error to what we saw before, where it says attempt to call a nil value, because we're trying to invoke the doStuff function before we actually declared the getAge function that doStuff is dependent on. So you just want to be aware of that when you are declaring your functions. You need to make sure that any of your functions that don't have any dependencies are kind of defined as high up inside of your source file as possible so that they don't accidentally get referenced by other functions and they're not defined when they need to be, right? So just be aware of function definitions. You can also have function definitions inside of function definitions, so we can nest these function definitions. So this works perfectly fine. We can declare the getAge function inside of the doStuff function and then call getAge after it's been declared. So let's go ahead and try that. Sure enough, it works perfectly fine. Now, remember that we have local and global scope when it comes to functions. So if I tried to call getAge after we call doStuff, so when we call doStuff, the first thing that we actually do is we define a function called getAge as a global function because we don't have the local keyword in front of it. So we should be able to actually call getAge outside of the scope of the doStuff function because we're declaring it as a global function. And sure enough, you can see that that does work perfectly fine. But if we change the scope of the getAge function by using the local keyword on it right here, well, now we're going to run into a problem once again because we tried to call the getAge function, but it's not a global function, right? Now it's a local function inside the scope of the doStuff function. So if we try to call it out in the global scope right here, then it's going to ultimately fail. Now, something else that's interesting about functions is that functions can be assigned to variables to define them rather than using this function name, arguments, and things like that. What we can actually do is go ahead and just create a variable. So I'll create a variable called getAge. Actually, let's go ahead and just paste this in here so I can keep this all the same. But then what I'm going to do is actually take the function name away, and I'm going to put it in front here. And we're going to define a variable called getAge and set the value to a function, but the function doesn't have its name declared in line. Instead, getAge, the variable, actually contains a reference to this function and any corresponding arguments, which in this case, of course, we don't have any. So that is also a valid way of building your functions, is to either use function followed by the function name, or you can assign an anonymous function to a variable, and then you can simply reference the function with that variable. Now, something else that's interesting is you can actually pass functions around as arguments. So you can pass in a function as an input argument to another function, and you can actually return a function as a value from another function. And there's a lot of cases where this is really useful, but unfortunately at the moment I just have to come up with a contrived example. And so let's do age here. We're going to declare a second input argument. We have one input argument, which is first name, then we have a second input argument, which is first name. So rather than calling getAge here, all right, all we're going to do is declare the function getAge. We're going to declare the function doStuff. But now what we're going to do inside of the doStuff function is we're going to call age. All right, so whatever function gets passed in for age right here is going to get executed, and we can swap it out. So I could declare maybe two different getAge functions here. Let's do getAge and getAge2, and this second one will be 45 instead of 35. So now we have two different kind of helper functions defined. But when we call doStuff down here, we're going to pass in a function for this age argument, and doStuff doesn't care what function I pass in. It's just going to call that function. So down here, we'll pass in getAge, but we don't put the parentheses after it because we just want to pass a reference to the function. We don't actually want to call the function and then pass the results of the function into doStuff. We literally want to pass a reference to the function itself. And then inside of doStuff on line 11 here, that's where we actually invoke the function. But we invoke it using the argument name, not the actual function name that was assigned at the global scope of our Lua program. So if we try to run this here, you can see we get hello Trevor from line number 10 right here when we call the doStuff function, and your age is 35. So we called the function that we passed in as an input argument to doStuff. Now, if we want to change that, all we do is swap it out by changing the name of the function that we're going to pass in. So if I re-execute this, now we get hello Trevor, your age is 45, because we actually passed in a reference to this second function right here rather than this first function that we declared up here. So that's how we can pass in a function as an input argument to another function. A pretty cool capability. We can also return functions from functions. So what I want to do here is in getAge2, I'm going to say return function, and then we'll do an end statement here. And we're going to return a function that says print your age was 45, wasn't it? Question mark. All right, so think of this selected text that I have right here as one segment. We're declaring an anonymous function, and we're just returning that as a value back from the function. We haven't talked about function return values yet. I get that. So this is a little bit more of an advanced case where we're not just returning a number or a string or a nil value or a table. We're actually returning a function definition as a return value from a function. So now what we can do is call the getAge2 function. So what's going to happen here is the first thing that's going to happen is we call getAge2. It's going to print out the text on line number 6 here. And then getAge2 is going to return a function without executing it. It's just going to return the definition of it. So now the definition of the function that's getting returned from invoking getAge2 is going to get passed in as an input argument to the doStuff function here. And then that function definition that got returned from getAge2 is actually going to be the age input argument that gets invoked here on line number 14. So now, if we run this, the order of operations is getAge2 runs first. We get this line on line number 6 right here. It returns this function definition back to the global scope here, and then that function definition gets passed in to doStuff. So then doStuff says, all right, I'm going to run line number 13, print out hello Trevor, and then I'm going to execute or call whatever function was passed in to this second argument here, which was the function that we returned right up here. And so then it prints out your age was 45, wasn't it? So very interesting how you can do that in Lua. You can just kind of pass functions around as inputs or outputs from functions. It's just very flexible from that perspective. All right, so we've talked a little bit about functions here, local versus global functions, return values. Also, we briefly saw this earlier, I think with the math.max and math.min functions, how there were triple dots, 3 dots. Not 2 dots, but 3 dots. So when we have 2 dots, that's string concatenation. When we have 3 dots as a function argument, that's where we can specify an unknown number of function arguments. So let's say that we want to pass in a couple of strings into a function. So we'll create a function here called print stuff, say end, and I'll give it a capital letter here, so it's a global function. And now, rather than having like first name and last name, now what I'm going to do is actually pass in ... Okay, so I can have an unknown number of items that I actually pass in to this function here. So now, if I want to, I could say print, and then we can print out hello, and then we can print out ... directly following that. So now, if I call print stuff, and I just pass in Trevor, let's try this out really quick. So now you can see it says hello Trevor, but there's this odd gap in between there, right? It's not just hello space Trevor, it's hello and then like almost like a space and then a tab character, right? And so what's happening here is it's kind of treating these triple dots almost like a table, like kind of like an array of values, right? And so what we can do is actually take these triple dots and wrap it in a table so that we can then reference the items inside of that. So let's say let args equal, we'll do curly braces and then triple dots. Or actually, I'm thinking in Rust terminology here with the let keyword. Let me do a local keyword, args, and then we'll wrap those arguments in a table. And so now I think I should be able to index into that table and grab the first element of that table. So now it looks like we get hello Trevor right there. So I don't know if that's actually working the way I expect it to. Let's go ahead and pass in a second one like Trevor and Joe maybe. So now we're passing in 2 different arguments. So let's try to run this. So we get hello Trevor once again. And the reason that we're getting that extra space actually is because of this comma here. So what I meant to do was actually do double dots right here. And that should just give us the space in there. Yeah. So now we have hello Trevor. So what we can do is take these triple dots, wrap it in a table, and now we can treat it like an array, even though we're passing in these kind of distinct arguments, where normally you'd have, you know, named arguments like A1, A2, A3, and so on and so forth. But now, instead of doing that, we're just referencing it as kind of an array of various arguments that we're kind of feeding in there. Now, something else that's interesting is that you can actually mix and match data types in tables. So I don't know if we talked about this earlier, but tables don't all have to have the same data types. We could have, we actually did, because we had like orange, nil, bacon, that kind of thing. But we could actually pass in 2 different arguments here and these would still be referenceable separately. So one's a string, one's a number data type, and we'll say dot dot again here and say period, your age is space dot dot args 2. Okay. So essentially what we're doing here, and I'll split this across a couple lines here just to make it a little bit more readable. We're saying hello space first name, right? And the first name just coincidentally is the first argument that we're passing in to the print stuff function. Then we're concatenating again. We put a period at the end of the sentence. Then we say your age is space, concatenate, and then grab whatever the second argument is. And in this case, the second argument is actually a number. So if we try to run this, it says, hello, Trevor, your age is 35. So again, the triple dots here allow you to just take an arbitrary number of arguments and pass them in. And then once you have a table here, let's say that we were iterating over a bunch of items like Trevor, Joe, Sally, Nancy, Era, Sid, Tifa, that kind of thing, right? So we have, in this case, I guess 7 arguments, right? But I don't necessarily know that it's 7. Well, what we can actually do is iterate over the elements inside of a table using something known as a for loop. And we haven't talked about control flow statements yet, like if statements, while statements, repeat statements, for statements, and that kind of thing. But what we could actually do, let's say that we wanted to print a greeting, like a hello for each of the names that's passed in to these triple dots here. Well, now that we've turned the triple dots into a table, what we can actually do is use a for loop to iterate over each element that's inside of the table. So what we can do is use a couple of placeholders here, I and V, and say in args, which is a table, do end. Okay. So this is a new construct here. This is a control flow statement that allows us to iterate over elements in an array, or in this case, in Lua, it's a table. But what we can do is actually use this function called pairs. And the pairs function is going to break this table down into the index and the value. So index number 1 is going to have a value of Trevor. Index number 2 is going to have a value of Joe. Index 3 is going to have Sally, and so on and so forth, right? So then what we can do is use the V here to reference the value for each of these inputs to the function. So we'll say print hello space dot dot V. And then for every iteration of this loop over each element that's being passed in here, we'll print out a greeting for each of those. And then we don't necessarily need the index, so I'm just going to discard that by using an underscore. So let's save this and run our code here. And now you can see that we pass in all of these strings as inputs to our function here. We turn it into a table. We call the pairs function on it so that we can break it down into index and value. We discard the index, but we keep the value and assign it to a variable called v. And then we just use string concatenation here to print out a greeting to each person's name. All right. So that works pretty well. Something else I wanted to talk about, though, is this actually brings me back to function arguments. So doing multiple function return values, right? So we've taken a look at how to do multiple input arguments when you have an unknown number of inputs. But something else that we can do is have multiple outputs. All right. So let's say that we have a function here called people. Okay. And then inside of this people function, we're going to return a table that contains several different names. Okay. So this time, rather than passing in multiple arguments, we're actually going to return multiple values as part of a table. So what we'll do is say Aerith and Tifa and Cloud. And then over here in our program, we can say people equals, actually do local people equals the result of the people function. And then we can print out people, let's say index number 2, right? So we'll index into this table and we'll grab the second element, which should be Tifa right here. And sure enough, we get Tifa back. Now, this is an example of returning a single argument because this is a single table that we're returning from the entire function. So when we call the people function and we populate this variable called people, lowercase people, it's a local variable, this people function has a table, a singular table. So if we print the type of the people variable, it should tell us that it's a table type. But remember that we can actually return multiple values, multiple individual values, not wrapped in a table from a function. So in this case, we're going to return 3 values. We're going to return a string Aerith, we're going to return a separate string Tifa, and a separate string of Cloud. And so in this case, the way that we handle this is to specify different variable names. So we'll do local p1, comma, p2, comma, p3, and now p1 will contain Aerith, p2 will contain Tifa, p3 will contain Cloud. So down here, we'll say print p1, go ahead and just duplicate this and say p2 and p3 as well. And so now it should just print out Aerith, Tifa, and Cloud. But let's say that maybe one of these values we wanted to discard. We just don't need one of these values, like P2 here. So we could say underscore, and that will allow us to skip over a variable assignment. Even though the function's returning 3 values, we're just going to discard whatever the middle value is, and we're just going to capture the first and the last values from this function. So now we have Aerith and Cloud, but we skipped over Tifa right there. All right, so that's function return values. Now, there's a lot of stuff to discuss when it comes to control flow statements. So we can do if statements, we can do compound if statements with multiple criteria. We can do if else statements. So if a condition is true, then do this, else do something different. We can also have else if statements. So we could say if this is true, then do this. Otherwise, if this is true, then do this. Otherwise, do something else. So let's say that we are, looking at like driver's license information, and you have to be at least 16 to get a driver's license. So I'll just create a variable here called age and set it to 15. Okay, so you're not old enough to get a driver's license. Let's say you have to be at least 16 to get a driver's license, or at least a permit or something like that. But we'll just simplify it and say license for now. So our current age is 15. And now we want to say if age is greater than or equal to 16, then we can get a driver's license, right? So this is a simple if statement. And we'll say print, you are eligible for a license, driver's license. Okay. So if we run this, we don't get anything back because 15 is not satisfying this condition here. It's false, right? 15 is not greater than or equal to 16. If we change the age variable to 16, well, now we are eligible for a driver's license. So this if statement passes, this little expression here returns a true value. And so therefore we are able to print out the code in the body here. Now, let's say that we wanted to have something happen if you're not old enough, right? So right now we're only handling the condition or the situation where somebody is old enough. But if they're not old enough, we just ignore them, right? But let's put in an else statement here. So if you're greater than or equal to 16 years old, then we say you're eligible. Else, if you're not older than 16 or at least 16, then we'll say you have a bit longer to wait, period, 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 triple periods, dot, 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 whatever you want to call it. And now if we run this program, it says you have a bit longer to wait because our age is 15. We change the age to 12, we still get the same thing. If we change the age to 18, well, now it says you're eligible again, right? But let's say that there's some other situations that we want to handle, some other criteria. So I think in the US, there's this age in the insurance industry, like 25, where after you reach the age of 25, you are considered a safer driver for whatever bizarre reason. I don't really know why age has anything to do with it. But if you're older than 20, if you're 25 or older, then you are generally paying less for insurance than if you're under 25. So what we can do is say if your age is greater than 16, then you're eligible. But if you're 25 or older, then you are eligible for a lower rate on your insurance, right? So what we could do is satisfy conditions where you are greater than or equal to 16 and less than 25. So we'll say and age is less than 25, but we'll say else if age is greater than or equal to 25, then we want to say print you are eligible to drive and have reduced insurance costs, exclamation point. All right. So if you're just starting out driving, you're eligible if you're 16 to 24. If you're 25 or older, you're eligible to drive, but you have reduced insurance. Otherwise, if you're not matching any of those conditions, then you get the kind of catch-all, the exception case here, in which case you have to wait a bit longer in order to drive. So now we're kind of satisfying all the different conditions inside of our program here. So if our age is currently 18, that falls into this criteria here. So line number 4 runs, but if we change our age to 34, then it says you are eligible to drive and have reduced insurance costs. We change our age to 12, then it says you have a bit longer to wait, right? So this is a simple if statement. We have if else, if else, if else, and we also have these compound criteria here. So you can use and, you can also do or. So, if you like oranges or bananas, then you can do something. So let's say like local fave food equals orange. And we could say if fave food equals orange. And we actually want to use double equals here for equality, for comparison, or relational operators, as they call them. Or if fave food is equal to spinach, then let's go ahead and put that on a new line there. Then we'll say print you like healthy food. All right. So if we run that, because fave food is equal to orange, then it says you like healthy food. And then we could put an else statement here and say print you like unhealthy food. Okay. So now if we change this to something like my favorite food is cookie and try to run this, then we have this exception case down here. But really what I'm showing you here is that we can use either or. So we already tested orange, but what if I change this to spinach? Well, spinach is a healthy food as well. So it says you like healthy food. So that's if statements. We also have the ability to do while statements. So we could say while true, this is basically an infinite loop where true is always true, right? And then we just say end. And we could say print Lua rocks. Okay. So if we run this, this is just going to run forever. Okay. So we want to cancel termination of that. So I think we want to hit stop there. And so now what we're going to do, actually, let's do F1, stop code, run, Control Alt M is the shortcut for that. So now what we want to do is say while, let's say age is less than 16, print you can't drive yet. So we need a variable called age. Let's do local age equals 10. Okay, so while your age is less than 16, you can't drive. But every time that we tell somebody they can't drive, we're going to add another year to their age. So we'll say age equals age plus 1. So we start at age 10, and as long as your age is less than 16, then you can't drive. But once you hit 16, then you can drive. And then we'll exit out of the loop. So if we run this, then it says you can't drive yet, but it only prints that out 6 times, 10, 11, 12, 13, 14, 15. And then once it reaches 16, then it just exits out of the loop and it continues on with our program. So we can say print, you are now eligible for a driver license, exclamation point. Go ahead and run this again with Control-Alt-N. And now you can see it says you are now eligible for a driver's license, whatever you want to say. I just didn't want to put the additional single quote in there. Now, you can also do something else. So while statements are not always guaranteed to execute, so let's say that our age was 16. Well, if we run our program, it just jumps to line number 6. It never, ever actually executes the code inside of the while loop here. Now, if you want another type of loop that will execute at least one time, you can use a repeat until condition. So what we'll do is change the while do to repeat until age is greater than or equal to 16. And I think this is what's going on here. Of course, I totally forgot the syntax here. So it's actually repeat at the beginning. And then at the end, instead of having an end statement, we say until and then the condition. So we don't use the end keyword in this case. Just the syntax kind of slipped my mind there. We just say repeat X, Y, and Z until the age is greater than or equal to 16. So now, if we run this, scroll to the end, it operates very similar to the do while loop. But if we set our age to 16, let's go down here, you can see it always executes at least once. So even though our age was already 16, it executes the block, and then after it executes the block at least one time, then it checks the condition to see if it should do it again. So there are, in PowerShell, for example, there's a couple of different types of loops. There's while loops, and then there is, I think, a do until loop or something like that. And there's just really some subtle differences between them. One of them executes if a condition is met. The other one will execute at least once and then check the condition. And that is what the repeat until statement is doing here. It's always executing the block inside of here at least once. All right, so that's the repeat until. So now let's talk about gathering user input from applications. So far we've been just hard coding values into our application, but let's say that we actually wanted to, prompt a user for something. So what we could do is say print, and then say, what is your name? Question mark. And then we'll go into this IO module here. So if we go over to the documentation for Lua here, and we go to the IO module here, you can see on the far left, if we do io.read, this will allow us to read some input data. All right, so if we do io.read, it'll go ahead and actually read some data that we pass in. So let's do first name equals io read. Let's go ahead and run that. And what's going to happen is it's actually going to block until we pass in some information. So what I'm going to do is actually, instead of using Code Runner, because Code Runner can't handle interactive inputs there, so what I'm going to do is switch over to our terminal down here. And what we're going to do is run our Lua script by doing Lua Trevor.Lua. And so now you'll see that we don't get our prompt again here, our shell prompt. We actually get this pause in execution. And now I can just type my name, Trevor, and our program exits. So it assigns the results to this variable, and then it just exits here. But you'll probably see that the input is on a new line here. So one of the things that we can do to mitigate that is to actually use something else called io.write instead of print. Let's just change this to io.write. What is your name? We'll put a space at the very end right there. And I didn't want to use Code Runner. I'm just doing that by habit. Let's go to our terminal, run our script. Now you can see that my cursor is prompting me for the name right after the prompt, but it's keeping it all in the same line, right? So now I could type Trevor all in the same line, and it's a lot more concise there. So now that we've populated that variable with some user input, we'll say print, well, thanks for joining us, comma, and then we'll do a concatenation here. Let's do a double dot here and then say first name, and then do double dot and then exclamation point. So now we are accepting some input from the user, and then we're just printing a simple prompt here based off of the person's input. So if we try to run this again, we can plug in our name. Whoops, misspelled that, Trevor. And it says, well, thanks for joining us, Trevor. And then if I run it again and type in a different name like Billy Bob, now it says, thanks for joining us, Billy Bob. So now we can make our programs interactive by accepting user input. But the user input is actually being interpreted as a string. So let's add another prompt that says io.write, what is your age? And so after we prompt for that, we'll say local age equals io.read. And then let's say we want to print out whatever age you're going to be the next year. So next year, you'll be X, right? And so what we want to do is basically take age and add 1 to it. So what do you think is going to happen if we attempt to run this? Well, let's find out. So what is your name? We'll say, Trevor. What is your age? 34. And next year, you'll be 35. So it did actually successfully interpret that as a number. But if you want to be a little bit more explicit, you can always use the global function called toNumber. And that will just make very sure that whatever is being read from the user input here is being interpreted as a number. But keep in mind that this will break if you try to pass in anything that's not a number. So if I do ASDF, you can see that our program errors out because we cannot turn a string like ASDF into an actual number and then do a mathematical operation on it. So that's a condition that you would have to kind of deal with in case somebody puts user input that is not valid based on what you are expecting. All right, let's talk about the table data type in a little bit more depth here. So tables, again, act as arrays as well as dictionaries. We've seen how you can have a array of multiple elements, right? That could be multiple names. It could be multiple foods as strings. You can mix and match data types as well. But there is actually a table module that lets you manipulate tables as well. So we just took a look at this IO module that allows us to read as well as write data to the terminal. But if we go back to the Lua documentation, we can see this table module right here where we can concatenate, we can insert, we can move, we can remove items, we can sort tables as well. So let's talk a little bit more about the table type. I'll do a local variable, t1, or how about, let's call it t names, and we'll set it to a table, and we'll do arith, we'll do comma cloud, we'll do comma tifa, and then these are coincidentally sorted. So let me actually put a comma at the very end here. You can have a trailing comma, which is really nice. Even if you don't have another item, you can just leave a comma on the end. But let's move Tifa up to the middle here. So now we have ATC, but for them to be in alphabetical order, we would have ACT, right? So one of the things that we can do with the table module is actually to sort the table that we have right here. Let's actually add in another item just to make it a little bit more interesting here. So I'll do red 13. These are characters from a game called Final Fantasy VII that I am a huge fan of, and a new version of the game just came out called Final Fantasy VII Rebirth, which kind of continues on from the Final Fantasy VII Remake. So that's where these names are coming from, in case you're curious. And so now we should have ACURST, so ACRT, right? So let's go ahead and sort the table. So we'll do table dot sort, and now we can just pass in the table that we want to sort as the first argument. So we'll say table sort t names. And so now if we print out that table, t names, it'll print out the table elements with tabs in between. So if we do Control Alt N right here, actually, I thought it was going to do that, but in this case, it's just printing out the memory address. What we really want to do is iterate over the elements. We'll say for item in the names do end. I think this will probably work. So we'll just print out each item in the table here. And so let's actually use the pairs function here again. And then we'll get index and item, or index and value, depending on what your preference is. Let's go ahead and run that. And now you can see it went from Aerith Tifa Red 13 Cloud to Aerith Cloud Red 13 and Tifa. So this sort function is automatically going to sort for us. We could also do it based on numerical values. So let's say that we had, actually before we do that, I just want to show you what it looks like before we sort. So let's move the sort statement after the for loop. And then let's run it again. And so now we get Aerith Tifa Red 13 Cloud, which is the order that we specified it in our code. But if we put the sort statement before, we actually iterate over it, then it's iterating over a sorted table, right? So we could also do this with numbers. So let's do local t ages equals table. We'll say 38, 23, 73, 27, 38, 42. All right. So here's a bunch of ages. 73 should be at the end. 23 should be at the beginning if it was sorted, right? So let's go ahead and copy this code here. And I'll just iterate over t ages. Let's go ahead and run that. And because we're not sorting it, we start with 38, 23, 73, 27, just in the exact order that we have right here in our code. But what we can do is do table.sort, say t ages, and it just does an in-place sort. It doesn't actually generate a new table. It's just doing an in-place sort. It's sorting the existing table rather than creating a new table that is sorted. So that's why we don't have to assign a new variable with like called sorted ages or something like that. So now that we sort it, we'll go ahead and run it again. And now you can see that all the ages are being displayed in numerical order in ascending fashion. So 23, 27, 38. We actually have 38 in there twice. I didn't realize that. 42, and then finally 73. So that's how we can sort tables. We can also do table concatenation. So let's take a look at table concat right here. And so table concatenation is going to allow us to take a list. So given a list where all elements are strings or numbers, it returns the list followed by the separator. So for the example where we have a bunch of names up here, we have names like Aerith Tifa Red 13 Cloud. Right now, we are iterating over every single element in the table, and we are printing it out. But let's go ahead and comment that out. And what we'll do instead is simply do a print statement here, and then we'll say table dot concat, and then we'll pass in our table, which is tnames, and we'll pass in a separator character, which is also a string. So I'll just use a comma as the separator there. And when we run this program, the concat function is going to return a single string that's been joined together. So some other languages will actually call this a join operation, where we're taking an array of strings and we're joining them together based off of some separator value. And in this case, it's going to be a comma. But we could change the comma to a pipe character. You know, if you're working with CSV data, this might kind of look familiar. You have commas or pipe characters or some other character that you're using to separate each of the elements in the list. And so that way we don't have to worry about writing a for loop. We can literally just present a string with all the names combined as a singular string. All right. Now, one of the other things I wanted to talk about is the ability to remove an item from a table. So tables also have this remove function here, and you can remove an item at a specific position. So there's only two arguments. There's the table that we are attempting to mutate or modify, and then there's a position that's optional. And it says if we don't specify a position, then the default value is pound list. And remember that the pound sign allows us to get the length of a table or a string. So if we have a table that has 5 elements and we take a look and we inspect pound table, then the length that we get back is going to be the last element. And so if we don't pass in a position, basically what the documentation is saying here is that it's always going to take the last element and remove that. So now that we understand how that function is working, let's go ahead and before we print out this list of names right here, let's actually get rid of this code down here just to make the output a little bit more brief down here. So now after we sort, what we're going to do is say table.remove, and we'll pass in the table name. So we sort the names and we take the last item off of the table, and then we concatenate the remaining elements based on the pipe character. So now Tifa is no longer going to show up on the output here. But if we put the remove operation before the sort, then if you look at the items that we declared in our code right here, cloud is actually the last element inside of the table. So if we remove the last element and then sort, cloud was removed before the sort operation happened. So now cloud is the one that got kicked off of the table, right? So there's a bunch of helper functions on the table module right here. And again, tables built into Lua, so you don't have to import the table module separately. But you can actually develop your own modules as well, and then you can import those into your program. Now, another one of the modules that I wanted to talk about is the operating system module. And so what the OS module allows you to do is things like execute external commands. And this is particularly helpful if you want to call out to some other helper program. So maybe from a Lua script, you want to go kick off a PowerShell script or a Bash shell script, or maybe you want to kick off a C# program that you compiled into a binary, or maybe a Rust binary that you want to call from your Lua script. Well, the operating system module allows you to execute external commands. It allows you to get environment variables, and it allows you to get the current time as well. So if we take a look at the documentation for Lua and take a look at the OS module right here, we've got a bunch of different helper functions. os.execute is the one that's going to allow us to actually execute external commands. So if we take a look at os.execute, it's basically equivalent to the C system function that executes a command in the system. And so we can simply specify the command and any arguments that we need to pass into that command in order for it to work. So let's say, for example, that in our project folder here, we create a text file, trevor.txt. Okay. And now let's say that we wanted to delete the file trevor.txt, or maybe we have a bunch of files like trevor02.txt, and now we have 2 different txt files. Let's say that we wanted to delete those files, but we don't have the ability to delete multiple files with the remove function, which is another function available on the OS module. So we could say os.remove trevor02.txt. So I actually want to put that inside of my Lua file. So let's go back over here. And now we'll go ahead and run our Lua script. And you can see that immediately that file disappears from our file list. Now I could change the file to trevor.txt, run that, and it works fine, right? So os.remove allows us to delete some files, but we're deleting all of these files individually. What if I wanted to use the rm command that's built into Unix systems to delete a wildcard like rm star.txt? So let's create t1.txt. Let's create another file here called t2.txt. And so now I want to delete both of these with a single command. Well, what we can do is use os.execute, and then we can specify a shell command that we want to run. So in this case, I'm going to use rm star.txt to delete all of the .txt files inside of this directory. So if I do Control-Alt-N, you can see that we run the rm command. So rather than running Lua code this time, like the os.remove function, we're actually calling out to the rm utility, which is a totally separate binary on the Unix system, and we're invoking that command, and it's doing what it needs to, and then control is returned back to our Lua program so that we can continue writing Lua code. So the OS module here that's built into Lua can be very helpful for things like that. Now, something else that we can do with the OS module is to get environment variables. So we've got this os.getEnv function, and it just takes a single argument, which is going to be a string that contains the name of the environment variable that you want to retrieve the value for. So if we go back to our shell here, let's go to our interactive shell in VS Code. We can do things like echo $home, or we can run the set command here, and that'll actually spit out a list of a bunch of different environment variables that we have. And there's a bunch of stuff in here, so we'd have to kind of skip over all that. But there's a bunch of built-in environment variables in the system. And so if we wanted to show the value of an environment variable, let's do export first name equals Sally. All right. So now if we do echo first name, we get Sally back. But let's say we want to do that from Lua, right? We don't want to do that from Bash. We want to do it from Lua. So what we'll do is say os.getEnv, say first name, and we have to capture the return value. Otherwise, it's going to complain. So we'll say local first equals the result, and then we'll say print hello, welcome to Lua, comma, string concat, and just plug in the first variable there. So this is a really simple program that just reads an environment variable and then feeds it into a string, all with Lua. So now we'll run our Lua script from our shell, and it says, hello, welcome to Lua, Sally. So rather than setting a variable inside of Lua, we're setting our variable as an operating system or shell environment variable, and then we're using Lua to retrieve that value. Something else that's interesting is that we can work with files. So previously, we took a look at io.write on how to write to the terminal. We also took a look at io.read that allows us to read user input and assign the results to a variable. But the IO module in Lua can also be used to work with files on the file system. So let's take a look at how to do that. So when we did io.write, it wrote to the terminal, right? And that's because the default target location for the IO module is the terminal. But what we can actually do is call this io.output function here, and we can specify a different file name that we want to interact with. So what we could do is say io.output, and then we'll specify a file like trevor.txt. And then we also want to make sure that we close the file once we're done with it. So we always want to call io.close as well so that we don't have any open file handles after our Lua program terminates. So now In my terminal down here, I'll just do an ls command, and you can see the only file that I have in my directory here is trevor.lua. And so if I run my Lua script and do ls again, you can see that I now have a trevor.txt file inside of there. Now, if I actually open up the trevor.txt file right here, I'll actually use a nice feature of VSCode that allows me to open them up side by side right here next to each other so that we can see in real time the file contents as it's being mutated. So right now it contains absolutely nothing, right? And that's because we specified to output to that file, but we didn't write anything to the file before we closed it. So what we can do is call io.write. Now that we've changed the file path that we are interacting with, we can say io.write hello from Lua, Trevor Sullivan, right? And then if we run this program from our terminal, you can immediately see that in VS Code here, we get this text printed to our file. Now, one of the things that we can do if we want to create a new line in the file is we can say io.write, and then in our string here, we can do a /n. We didn't really talk about escape characters before with strings, but there's a variety of different escape characters, like a new line, or /t would be for a tab character and things like that. But we can just do /n to create a new line ending in the file, and then say hello from me, okay? And then if we run our program again, it overwrites the contents of the previous file, right? So it basically starts from the beginning again. It says hello from Lua, Trevor Sullivan, and now it created a new line character, and it says hello from me. Now, when you actually open a file, you don't just have to open it up for writing. You can also open it up for appending. And so there's another function available in the IO module here called io.open. And when we call io.open, what it's going to do is it's going to allow us to specify a file mode that we want to open it for. So what we could do is say, I want to open the file for appending. So I don't want to delete what's already in the file like we just did. So every time we write the file, it's replacing the contents with whatever we specify. But if we open the file for appending, then it's going to add content to the end of the file. So what we'll do is say, let's comment this out for now. And then what we'll do is say io.open trevor.txt, and then we'll do comma, and then specify a for append. And let's see, this is going to give us a file handle this time. So we'll say local my file equals io.open. So now this my file variable is actually going to contain a file object, so to speak. I think it's actually a table type. Let's do a print type my file here and go ahead and run that. It's actually a user data type here. But what we're going to do is say my file colon, and now we actually have these functions that we can call on this file reference, right? So this variable my file contains a reference to the file, and we can call these various functions on that file reference. So we always want to make sure that we close the file when it's done being used. But before we close the file, we'll say my file dot write and say here is some more text. And we'll put a new line at the very beginning there. So we'll go ahead and save that, rerun our program, and immediately you can see a new line appears with here is some more text. And every time that we run that, it's going to go ahead and just add a new line to the end of that file by appending it. So that's a pretty cool capability that we have, is to open a file for writing, for appending, for reading, and we can then manipulate that file. So a lot of interesting things that we can do there. There's also an operating system time. So we're going to go back to the operating system module, actually. I was going to talk about this earlier when we were talking about the OS module, but there's os.time. And what this is going to do is it's going to return the number of seconds that have elapsed since the epoch, and I believe it's referring to January 1st, 1970 at midnight. And so the number of seconds that have elapsed since the epoch. And so if we just print out os.time, you can see that we get a big number, right? That's a lot of seconds since the epoch. But if we wait a few seconds and then run it again, you can see the number increases. And we run it again, and it just continues to increase for every second, right? So we can use this OS time thing to actually measure the performance of our code. So we could say print os.time, or actually let's get the time. So we'll say local start time equals os.time. And then we can say, duplicate that and say end time equals os.time. So now we get the number of seconds that elapsed when we started. And then somewhere inside of here, we can run some code. And any code that we run inside of here between these two lines is going to take up some time, right? And then we capture the number of seconds after our code is done, and whatever our end time is, subtracting the start time from it is going to be the number of seconds that our code took to actually run, right? So I could do something like a for loop here. So for I equals 0, so we'll start at 0, then we'll go up to 10, or maybe like 10,000 actually. They do, and then we'll just print A. Okay, so we're just going to print A 10,000 times and see how long it takes. I think that's still going to fall under 0 seconds, but let's find out. So we'll do Lua, and we need to do one more statement here that says print end time minus the start time. And sure enough, it is 0, right? Because this is running very, very, very fast. So let's try changing it to something like 10 million. Right, so this has taken a few seconds to run. And let's maybe try something like 1 million for starters and see if that's a little bit more realistic. Give it a couple of seconds here. All right, so there we go. So it took about 6 seconds for that code to run. So we can use this OS time function to basically take a snapshot of what the current number of seconds elapsed is since the epoch, and then we can compare that based off of other measurements, other snapshots that we take of our time at various points inside of our Lua program. All right, so one other thing I wanted to talk about here is, and feel free to explore the other OS functions and IO functions and things like that as well on your own, but I also wanted to talk about modules. So let's say that I wanted a helper module. I'll call this helper. Whoops, let's do a new file. We'll call it helper.lua. All right, so now I have trevor.lua. That's my main program entry point that we've been working with. And I also have helper.lua. Now, let's say that I wanted to create a function that I can use inside of my main Trevor program here, but I don't want this to be a really big file, right? I just want to call a function maybe a couple of times, and that's pretty much all I want to do, right? Well, so far we've been declaring our functions and our variables and all that kind of stuff inside of our actual main program. But what I can do is declare functions and variables inside of helper.lua, and I can actually export them from that module and then consume that module from inside my trevor.lua script here. So let's say that I wanted a function that generated some files, right? So I'll call this function gen files. All right, and we'll say end. And I'm going to turn this into a global function with a capital G right there. And then inside of this, I'm going to say for I equals 0 up to 10, actually 1 to 10, do end. And what we're going to do is say IO dot open, and let's actually just do IO dot output, and then we'll say Trevor I txt. So basically Trevor1.txt And then on the next iteration, trevor2.txt, trevor3.txt, and so on and so forth, right? And then we'll just call io.close each time. We'll also do io.write and just plug in some text like bacon into each of those files. So now we've got this function that just generates some kind of randomish files for us. And we want to be able to use this function from our main trevor.lua code file. So to do this, what we can do is actually use this thing called the require function. That's a global function available in Lua. So what we're going to do is say require and pass in the name of our module, which is helper. You don't have to put the .lua on the end. All you have to do is specify the name of the file that you're trying to load and return the result to a variable. So I'm going to call the variable just the same thing. All right, let's just call it h for short. All right. So now that we have h here, what we want to do is make this function accessible from trevor.lua. At the moment, it's not, but what we can do is say return, and then we can return a table. And I'm going to call this gen files equals the gen files function. So now with this return statement in here, we're creating this mapping between keys and values. So when I call gen files, it's actually referring to the gen files function inside of this helper module here. So now back on my main script, I can just call h.genFiles, put my parentheses to call that function. And as you can see, we just have one file in there called trevor.txt at the moment. But if I run the program, now you can see I've got Trevor 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 inside of this directory. So I've created this helper function here in a completely separate Lua module, a custom module that I created for myself. And I exported this function from that module, and then I imported it into my main program here, and I was able to use that functionality. Now I could create additional helpers as well. So I could create something like a cleanup function. Let's do function cleanup files and end. And then remember how we used the OS module that's built into Lua to execute an external program. So what I'll do is say os.execute rm star.txt. All right. And so now what I'm going to do is come down to my table where I'm exporting functions from my module, and I'll create an export called cleanup, and that will point to cleanup files. So the exported name doesn't have to match the internal function name, but when I call cleanup, it's actually going to call the cleanup files function from the module. So back over here in trevor.lua, we'll go ahead and do h.cleanup. We'll call that function. And so immediately after we generate some files, we're going to clean up those files by calling out to the rm binary. So let's go ahead and go down to the terminal and run my program. And as you can see right over here, all those files just disappeared from my system. So if I comment out the cleanup line here, I can run my program. It regenerates all these files. Each contains the text bacon. But if I comment out gen files and just run the cleanup, run my Lua program, you can see all those files get cleaned up. So pretty cool capability. It just helps to keep your code kind of structured and cleaned up so that you can define a bunch of helper functions into various modules for each purpose. And then you can go to your main program here and actually call that functionality with a much cleaner syntax. So anyways, this video's at about 2.5 hours, and I think I'm going to call it here. But I hope you learned something from this video. I'd really appreciate it if you left a like, a thumbs up on the video if you learned something new about Lua. Also, subscribe to the channel so you can get notified about future videos that I publish onto this channel. Most of it's kind of about programming, cloud, all that kind of software technology stuff. And yeah, check back for more videos. Also leave a comment down below just to let me know something that you learned or something else that you'd like to see on my channel, whether it's about Lua or Rust programming or any other technical topics. Thank you so much for watching. Again, my name is Trevor Sullivan, and we'll see you in the next video. Take care.